Think about it for a second. Electricity. It's basically magic, right? We flick a switch and light just appears. It powers everything in our lives, and we barely give it a second thought. But behind that magic, there's an entire system of rules, an invisible shield built for one simple reason: to keep us safe. So today, we're going to pull back the curtain and unpack the key parts of Korea's electrical safety code to see just how that shield works.
So what is this invisible shield, really? Well, it's a whole lot more than just the plastic coating on the wires, that's for sure. It's a massive system of laws, mandatory inspections, and super-specific engineering standards all working together. It's the carefully designed playbook that keeps our modern, electrified world from, going haywire.
And it all begins with the first line of defense, the pre-use inspection. This is a check that has to happen before any new building or installation ever gets hooked up to the grid. It's all about catching potential dangers before they even have a chance to become a problem.
And this isn't just a friendly recommendation, it's the law. As you can see right here in the Electricity Business Act, these inspections are required. It's not optional. This is how the system guarantees that every single new installation is up to snuff and meets all the technical safety standards before the power ever gets turned on.
So, who are these inspectors? These gatekeepers of safety? Well, it's not just one group. The job is split between two main organizations, and who shows up at your door depends entirely on the type of property. Let's break down who does what.
So take a look at this. For most everyday places like our homes, small shops, even farms, you actually get a choice. You can have the inspection done by either KEPCO, the big power utility, or by KESCO, the Korea Electrical Safety Corporation. But, and this is a big but, for the really specialized, high-power stuff like solar facilities or massive data centers, there's no choice. It has to be the specialists at KESCO.
All right, let's dive into the really juicy stuff, the core technical rules. We're going to start with two absolutely critical ideas: grounding and surge protection. The easiest way to think about grounding is as the ultimate emergency exit for electricity. It gives any stray, dangerous current a safe path to escape right into the earth, instead of through you or your equipment.
Now, the code has this really clever little feature called relaxed grounding. See, getting the standard really low electrical resistance for a ground, we're talking 100 ohms, can sometimes be tricky. So the code offers a deal. It says you can have a higher resistance, up to 500 ohms, but only if you install a special safety device called an earth leakage breaker, or ELB. This thing is a lifesaver. It detects even the tiniest leak of current and shuts the power off in a split second, which makes the whole system just as safe.
And this diagram shows it perfectly. Don't worry about the Korean text, just focus on the drawings. Over on the left, that circuit has our hero, the ELB, installed. Because it's there, the more relaxed 500 ohm grounding is totally fine. Now look to the right. That setup uses a standard main breaker, an MCCB, which doesn't have that super sensitive protection. So no special treatment for that circuit. It has to follow the much tougher 100 ohm rule. Makes sense, right?
Okay, so grounding handles faults inside the system, but what about threats coming from the outside? I'm talking about power surges, usually from lightning or glitches on the grid, that can absolutely fry our delicate electronics. That's where a surge protective device, an SPD, comes in. But you can't just slap one of these in any old way. It has to be installed correctly to do its job.
So what's the right way to install an SPD? Let's run through a few scenarios. First up, case 1. This is what you'd call a textbook installation. The SPD is wired up with its own dedicated protector, like a fuse or a small breaker. This isolates it perfectly from everything else. This is a completely safe and compliant method.
Now, case 2 here is a little simpler. The SPD is just connected right after the main breaker. It doesn't get its own little bodyguard. And that's totally okay, because in this setup, the main breaker itself is pulling double duty and protecting the SPD. This is also a perfectly acceptable way to do it.
Case 3 shows us another approved variation. Here, the SPD and its protector are wired in parallel with the main breaker, tapping in just before it. The advantage here is that the SPD gets to protect the entire panel. And, you guessed it, this is another completely safe and code-compliant approach.
And now for the one you absolutely need to avoid. Case 4. At first glance, it looks pretty similar, right? But look closer. There is a huge, critical flaw here. There is no protective device for the SPD. None. It's wired straight to the incoming power. If that SPD fails, and they do fail, there is absolutely nothing to stop a catastrophic fault. This is non-compliant and, frankly, a serious fire hazard.
So, we've seen just how critical breakers are.
Let's take a closer peek inside a normal breaker box and properly meet the electrical guardians that are on duty 24/7, protecting your home circuits, and more importantly, protecting you and your family.
Inside your panel, you basically have two main types of guardians. The big one, usually right at the top, is the MCCB, or the main breaker. Think of it like the main bouncer at a club. It's there to stop huge problems, like a massive power overload. The smaller ones are the ELBs. They're more like Secret Service agents for each individual circuit. They're looking for the tiniest, sneakiest current leaks that might mean someone is getting a shock, and they shut things down instantly.
And here's what they actually look like in real life. You've probably seen these before. Don't worry about all the little text printed on them. Just notice the different shapes and styles. They may look different, but they're all engineered for one crucial job: sense danger and trip the switch.
Now, the electrical code doesn't treat all rooms in your house the same. It can't. For high-risk zones, places where water and electricity get dangerously close, I'm talking kitchens and especially bathrooms, the safety rules get a whole lot stricter. From an electrical safety standpoint, this might just be the most dangerous room in your entire house. Water is a fantastic conductor of electricity, which just skyrockets the risk of a fatal electric shock. It's because of this simple, scary fact that the rules for bathroom outlets are the absolute toughest in the entire code. Here it is, the single most important point. Any outlet in a bathroom must be protected by a special, high-sensitivity ELB. A standard one trips at around 30 milliamps of leakage. The one for the bathroom has to be twice as sensitive, tripping at just 15 milliamps. And it has to be lightning fast. It has to cut the power in less than 0.03 seconds. That reaction time isn't just fast, it's literally fast enough to save a life.
So here's the first approved way to wire this up. You have your main breaker for the whole panel, and then, as you can see, the bathroom circuit gets its own dedicated 15 milliamp ELB. This ensures that any little fault in the bathroom is handled by the most sensitive device possible without shutting off power to the rest of the house.
Here's a second valid method. In this setup, the main breaker for the whole house is an ELB, which provides a nice base layer of protection. But, and this is key, that doesn't let you off the hook for the bathroom. As you can see, the bathroom circuit still needs its own dedicated, super-sensitive 15 milliamp ELB. The principle here is non-negotiable. High-risk areas demand high-level protection.
So, when you look at all these diagrams and rules, try to remember they're more than just dry technical stuff. An electrical code is a living document. It's constantly being updated with lessons learned from accidents, with advancements in technology. It's the silent contract, the invisible shield between the power grid and you, that makes sure the incredible force of electricity always remains our servant and never our master. It kind of makes you wonder, right? What other invisible systems are out there, keeping you safe every single day?